Welcome to another coding tutorial, and in today's video we'll be experimenting with some sound and movement to create this interesting track that you're hearing right now. This tutorial is an add-on to a video that I did in the past where a bunch of circles are moving in an oscillating motion, which is a movement back and forth around a center point. This time around, I'll be going a little bit faster and we'll also be approaching it a little bit differently. Specifically, we'll be using object-oriented programming. So I recommend you checking out the other video as well if you want a little bit more details. The add-on that we're going to do is that 1, we're going to have a circle play a note once it passes through a center point. And then 2, instead of creating just one ring of circles, we're going to be creating multiples to create interesting soundtrack. Why don't we start by creating the animation? So we're going to draw a circle in the middle of the canvas. I'm going to actually translate the origin point from the top left corner here to the middle of the canvas, and we can do that using a translate function. And then provide the 2 arguments of where you want to move the origin to. So we're going to put width divided by 2 and height divided by 2. And by doing this, now drawing an ellipse, I can just put in the new origin at 0, 0, and now it's going to be in the middle point. And I want the radius to be of the variable r, which I'm going to declare right now, and set it to 150. All right, and now how about we also do no fill? Now, how about we draw another circle, a smaller one, and have it be traveling on this circular path. So we need to use trigonometry, specifically the equation x equals to r times cosine of angle and y equals to r times sine of angle. Then let's set angle to be equals to 0. Then I'm going to draw this ellipse. Let's color it red, and let's draw it at the x and y location here and give it a size of 20. All right. And then now I'm going to also actually set the angle, map it to my mouse location between 0 and the width, and between the angle 0 and 360 degrees. And because I'm using the degrees mode, I also need to change the angle mode to degrees, and I can do that just by calling this function right here and provide the argument degrees. All right, so now as I move my mouse, the circle travels along this circular path. Perfect. But we don't actually want the circle to travel along the circular path. We actually want it to oscillate around a center point, which is the origin. So what we can do, basically, we just draw another ellipse at the same x location, but we want the y to be at 0 actually. And let's give it the same size. I'm going to fill it with the color white. And as you can see here, it is essentially just following the x coordinate of the red circle, right? Perfect. How about we also draw a line that shows the path that it is traveling in? So a line function takes in 4 arguments, the 2 coordinates of the 2 points that once connect become a line. So it's going to be negative r 0 and r 0. Now let's draw another circle that actually travels vertically. So what we can do is basically, how about I stop this from moving first? And then I'm going to draw out the same thing, but this time around we want to actually rotate the axis by a certain degree. So how about we rotate it counterclockwise by 90 degrees. So if I were to move this, so this will not actually give us the illusion that we want of the white circles traveling in a circular path. To do that, the white circles actually needs to follow the x and y coordinates of this red circle here. So what we need to do actually is that we need to give another variable and add it inside this equation here. So I'm going to actually declare a new variable called x2, and it will be r times cosine of angle plus shifting angle. And basically this shifting angle it needs to be shifted the same amount as the rotation. So how about we set let shifting angle equals to 90. And please notice that this is positive, but this one, the rotation of the axis is negative. All right, so if we do this, then now, oh, we also need to set this to x2. And now the white circles are tracking the x and y location of the red circles. So how about we do 2 more to get that circular motion illusion? So I'm going to actually declare this as 2. And then how about we do 2 more, and let's set it at in between, so 45 and 135. And then I'm just going to copy this 2 more times and then change this to 3, 3, 3, this one to 4, 4, and 4. All right, and also in here we need it to be shifting angle of 2, right? This one is of 3, and then this one is of 4. All right, let's run. Okay, and then this is not what we want. What did we miss? We missed 2 very important functions when doing any types of transformations, which are push and pop. And push basically saves the transformation, specifically the rotation here of negative shifting angle, and then pop returns it back to the original setting before we call the next rotation or the next transformation. So that's what we need to put in before and after each transformation. So push and pop. Push and pop here, and then the last one here, and this should fix it. All right, so now the white circles are moving. It seems like they're moving in a circular motion. Great. Why don't we put this inside a class first so that we don't need to copy and paste this set of code multiple times. So let's come to this arrow here, click the plus sign, and then click create file. We're going to call this file ball.js. And then before we start writing this class, let's go to index.html, then come to this line of code. Let's copy and paste. Change the name from sketch to the name of the new file that you just created. In my case, it's ball.js, and this is how you integrate a new JavaScript file into the program. All right, now let's go back to ball.js. To write a class, we start with the word class, and then I'm gonna call this class ball. And then inside the constructor function, what do we need? Let's go back. So we can keep the radius as global, so we don't need that. We want angle and we want shifting angle. All right, so let's start with these 2. So how about we set angle to be equal to 0, but then we set shifting angle as a parameter here. All right, and then now inside here, we don't really need this red circle anymore, so I'm going to actually delete it. And what we want is we want this set of codes, right? And this is going to actually be in another method. Let's call it display. We also want to set x as a variable here. So this dot x equals to r times cosine of this dot angle, and then this dot shifting angle, right? And then this also has to be this dot. All right, and then how about we do one more method called update, and then we're actually going to change the angle or increment the angle by how about 1 degree at a time whenever we call update. All right, let's start with that. So let's go back. Now we can delete all of this. And we want to still keep the biggest circle, which is up here. Then we can delete this as well. How about we just start by creating just one ball object? So let b to be equals to a new ball. And we need what? We need just the shifting angle, right? So how about we set the shifting angle to be 0? So it is actually just going to be at this point here. And then we're going to call update and display. All right, and then now the circle is moving in an oscillating motion around a center point. Great. So how about we create more of them? So instead, I'm going to create an array, and let's call it ball, and then also create another variable called num. How about we set num to just 2, and then to create new objects, we're going to use a for loop that goes from I equals 0 to I less than num, I plus plus, and then we're going to now set balls of I to be equals to a new ball object. But here we need to put in the new shifting angle, right? So let's see how we would calculate that. So if we have just one ball object, the shifting angle will be 0, right? But if we have 2, we want the shifting angle to be at 90 degrees, right? Just like what we did previously. We want to rotate the axis 90 degrees to the left. So what we need to do is that we need to use an equation 180 divided by num times I. So this way, if num equals 2, 180 divided by 2 is 90 times 0 is 0, and then times 1 is 90. So that's exactly what we want. Then we can just put in shifting angle in here. And then now we just need this same for loop to call these two methods. So it's going to be balls of I, and here as well. All right, and then now how about we change it to 4? How about we change it to 10? Perfect. Now that we have the animation done, why don't we start to figure out how to add on some sound? Let's come to this arrow here, click the plus sign, and then click create folder. We're going to be putting all of the MP3 files into this folder right here. I'm going to call it assets. And then you need to click this arrow here, click upload file, and then you're going to be drag and dropping your MP3 files in here. And then once your file is uploaded, you can just click this. And as you can see here, I have a total of 12 MP3 files, and this is of a chromatic scale. And a chromatic scale is essentially the 12 notes in one octave on a piano key. And then now what we want to do is we want to, how about we label this first? This is ball variables, and then I'm going to now set variables for our sound assets. I'm going to start by actually just uploading one MP3 file just to show you how to upload. So how about we set this variable called asset, and then we want to use a function called preload. And then this is going to allow you to preload your sound files onto the program before you start calling the other functions. All right, so what we want to do is that we want to set the variable asset to another function called load sound. And then you want to put in the location of the sound file that you have. So in our case, it's in a folder called assets. And then let's just do this a#.mp3 file. So you need to put in the quotation mark, put in the name of your folder, and then backslash, and then a#.mp3. Let's click run. All right, it's still working. And then now I'm going to show you how to play this file. All you need to do is put in the name of your variable here, put in dot, and then play, the function play. And it is as easy as that. Okay, so now that we know how to preload one file, how about we do it for all of them? Instead of setting just a variable called asset, I'm going to call it assets. So now we have an array of sound files that are arranged in a specific way. And this is just how I choose to do it. But you can actually play around with how you want to arrange these files. All right, and now inside preload, what you need to do is that you need to write a for loop that goes from I equals 0 to I less than assets.length I plus plus, And then we're going to be doing the same command here, but instead of a variable here, it's going to be a new array. Let's call it sound. And then let's do sound of I to be equal to load sound of assets plus assets of I. Let's click run. The loading text here tells me that it's not preloading properly, and I'm not actually sure why, but I found a way to fix it, and that is by, instead of putting the names like this, I just change it to this way of putting in the file names. So instead of doing assets / plus this, we can just do this. So if you actually know why this error happens, please comment down below. But if we do this, first we need to also comment this out. Let's click run. And now it seems to be preloading properly. So what we want to do now is that we want to go back to ball.js and we want to add in this .note as a new parameter. And then we're going to create a new method. Let's call it collision. And essentially, this method is going to tell us whether the ball hits the middle point. So how about we just do a conditional statement that says if this .x is equals to a specific point x, so this is going to be our parameter, then return true, else return false. Okay, and then inside update here, we want to call this method. And to call a method inside a class, all you need to do is put in the word this dot, and then the name of the class, and then we want to put in 0, right, which is the middle point. But this actually is going to be a conditional statement that says if this dot collision of 0 equals to true, then we want to play the note. And yeah, that's it. So let's go back to sketch.js. Now we need to add a new argument inside our object here, which is going to be sound of I. And let's delete this. All right, so let's play. But it's not playing. Why is that? So let's go back to ball.js and let's print this .x and x. So as you can see here, the location of the ball actually moves between negative to positive. So it actually hits 0, but it doesn't hit 0 exactly, and that's why it's really hard to get this .x to be equals to x. So how about we add some buffer to make sure that once it hits, but if it's off by a little bit, then still return true. So what we can do is we can add, actually I'm going to set it as a variable called buffer, and then add it as a new parameter here. So if this .x is greater or equals to x minus buffer, and this .x is less than or equals to x plus this .buffer. So this has to be this .buffer. All right, and then now if we go back to sketch.js, we need to add buffer. How about we set buffer at 1? Is that too small? Let's try. Seems to be okay. So I really think that it also depends on the rate at which you move the circle. So why don't we add that as an argument too, or a parameter? So how about I add one more, angle v for angle velocity, and then just set angle v to be equals to this. And then instead of increment it by 1 here, we're going to set this angle v here. Then we're going to come back here. And actually, instead of putting 1 here, I'm going to set it as buffer, a variable buffer and angle v. And then I'm going to come up here and then set buffer to 1. And then how about angle v to 1 as well, so we can adjust it easily here. All right, then how about we start smaller? You see that? It doesn't play all of them. So maybe you need to increase the buffer. But you can see here that it's kind of played the note twice. So this is where you want to adjust it a little bit. How about 1.5? To get the final result that you want, you can adjust the buffer and the angle V based on the number of balls that you have to create the sound that you want. But what if I want to increase the number of balls to be greater than the number of sound files that I have? Let's say I have 13 balls here. It gives me an error, and that is because why? It is because there is no sound of index 13, right? So what we can do is that we can loop it back. We can do that quite easily by using an expression called modulo. And basically modulo is this percentage signs where you want to do I mod and then the length of your array, which is sound.length, which is 12. And that is because this expression here returns the remainder between these two division I and sound.length. So let's say that you have I equals to 0 to 12. When you divide that by the length, which is 12, you get a return number of between 0 and 11. But once it is more than the sound length, let's say 13, right? So 13 mod sound.length, which is 13 divided by 12, you get a remainder of 1. We will always get an index that is between the length of the sound array. All right, so let's try this. Okay, so this is how we fix this issue. Before we move to the second add-on, I want to change the number back to 12, and then how about we set angle velocity to 1.5, and then let's do a buffer of 2.5. This seems to give a pretty good sound. The last add-on is to create multiple rings, and we can do that quite easily by how about just copy and pasting this for a loop here, so we create multiple more objects. And then we want to create another array. Let's call it balls2. And then we just need to change balls2 here. And then we want to call the method here, right? But you only see one ring, and that is because of the starting angle. We want the two rings to have a different starting angle. So how about we go back to ball.js, and we are going to add starting angle here as a new parameter. And let's set this dot starting angle to be starting angle. And all we need to do is that we just need to add this inside this parentheses here. So instead of having it start at 0 all the time, it will be starting at a new starting angle. So now all we need to do is how about we set 0 and 180 here. And then I'm going to stop it from moving for now. So now you can see that we have two rings, right? That start at 0 and 180. All right, so you can change it to, let's say 90. And then now you can see that this ring starts here. All right, so we can do it this way and it's fine, but it is basically copy and pasting, which is not as clean as I would like, and it's gonna be more difficult if we want to add multiple rings. So how about we actually create a 2D array? So we can delete this balls2 array, and we're gonna make this balls array from a 1D array to be a 2D array. So what do we need to do? What we need to do is we need to create a nested for loop. So let I equal 0 to I less than, how about we set another variable called loop, and we're gonna set loop to be 2. So I less than loop, and then I plus plus, And then we're basically going to put this other for loop inside here. Then I'm going to delete all this first. And then we need to make sure that all of this has to be j, right? So all of the previous I will become j. And then this is for a 1D array, right? So what you want is first, inside of this outer loop, we want to create a 2D arrays, and we can do that by setting balls of I to be equals to a bunch of empty 1D arrays. And then now balls of I of j will be a new ball object. And instead of 0 here, we also want to set the new starting angle, right? And how would we calculate this? If we want to space out the starting angle evenly, what we can do is we can do 360, which is 1 revolution, divided by the number of loop that we have, and then we just multiply it by I. So with 1 loop, it starts at 0, and then with 2 loops, it starts at 180. So now we just need to put in starting angle here. And now inside here, we don't need this second one. We just need this one. And then we want to actually do a nested for loop here as well, right? And then this will be inside here. And then change all of the previous I to j. Then this will be balls of I.j because now it is a 2D array. So let's actually stop it from moving first. So now we have 2 rings that are spaced out evenly. So we can just change the number of loops here. And that's it. Right, I'm going to keep it at 3. And then how about we uncomment this out. And there you go. Now we have this interesting track that sounds like when Mario meets the final boss. Okay, so how about we make it pretty, which is the last step. What I want to do is, first I want to set the background to black. And I also want to set the transparency to 100 to give it some of a blurring effect. And for the strokes of these circles, I want it to be white with a transparency of 50. And then inside ball.js, I actually want the circles to be smaller at 10, 10. And I think that's it. Let's try it. And then how about we play around? So if I were to do 8 at 4 loops, ooh, that sounds kind of happy. 5 at 24. Whoa! So this is so much fun to play around with. So I hope that this gives you a lot of ideas to experiment with. So give this one a try.